Okay, Mr. Kirby back here. Welcome to part two here. All right, so in this question, they're giving us a equation, and they're asking us to find the behavior of the curve. And if you weren't sure what they meant by the behavior, if you look at the answer choices here, it's clear that they mean, oh, tell me whether the curve is increasing or decreasing or concave up or concave down at this point. I hope you're thinking about increasing and decreasing being dictated by the first derivative and concavity being dictated by the second derivative. What's a little tricky about this problem? Oh, the y is not by itself. So when I do the derivative, I'm going to need to use implicit differentiation. I need you to remember this. What's the derivative of x squared? 2x. What's the derivative of 2y squared? 4y. But since I'm differentiating a y term, I need to put a dy dx there. Then I need to isolate dy dx. Okay, subtract 2x, divide by 4y. This is dy dx. Okay, I can plug in negative 4, 3 into dy dx, and I get out 4/6, which means my first derivative is positive, my function's increasing. These two are out of here. Now I need to find the second derivative. Well, I have my first derivative. How do you find the second derivative? Take the derivative of the first derivative. Okay, keep in mind, my y is still not by itself. I'm going to need to use implicit again. Low d high, less high d low, all of the denominators squared. For sure. When I do d low, I'm doing the derivative of a y term. So the derivative of 2y with respect to x is 2 dy dx. When I go and plug in to the second derivative to figure out whether it's concave up or concave down, I'm going to plug in negative 4 for x. I'm going to plug in 3 for y. And in the dy dx place, I'm going to plug in 4/6, 2/3, because that's what dy dx is at this point. Okay, so leave that dy dx there, because when you plug in, you need to remember to plug in what dy dx is at that x value. Okay, you should get out that it is, the second derivative ends up being negative, meaning my function's increasing because the first derivative is positive, and concave down because the second derivative is negative. Moving forward. Okay. Pause, read this question. This is a classic AP question. This is what we call a flow in, flow out question. Okay. In this case, the flow out, or the amount of calls they can process, is just 400 calls per hour. It's the flow in, that's this piecewise function they give you here, and they tell you an initial condition, that there's 300 people on the line to start. Okay? This is a classic question. Okay? First thing, how many people called by the end of the 6-hour period? Okay? They're not asking us about the flow out. They're not asking us about the initial condition. They're just asking us about the flow in. How many people have called? Okay? All I'm trying to do here is integrate this call in rate. Please note that this is the rate. So if I want to know the net change in calls and the total number of people that called in, if they give me the rate and I want to know the accumulation of that rate, I need to integrate the rate. So I'm going to find the area under this curve from 0 to 6, and that's going to tell me the total number of people that have called in. Okay, how am I going to do that? I'm just going to use geometry. Okay, cool. So let's chop it up here. 2 by 500, that's going to be 1,000. This is 1 by, that's 200, that's 100. I got this big triangle here that's 2 by 6. So I'm going to do 12 divided by 2. I'm going to get 600. I'm just doing geometry here. You guys know how to do geometry. That's 200. This is going to be 100. What's that going to be? 900, 1,000, 900. Oh no, Mr. Krabby. 900, 1,000, 2,000, 2,200. Okay. Please use the correct unit. 2,200 people have called in over the 6-hour period. Second question. Is the number of people who are waiting on hold increasing, decreasing, or staying the same between hour 1 and hour 2? So if I want to know whether the number of people is increasing or decreasing, I'm going to write a number of people on hold function, okay? This is kind of the core idea for this problem. This is the whole flow in, flow out thing, okay? So they give me a flow in rate, and if I integrate that flow in rate, that's what I just did in the problem above, it tells me the number of people that have called in up until a time t. But there's also a flow out, and that flow out is just 400 people per hour. That's just the rate at which they're processing the calls. So here's my flow in, here's my flow out, this is my initial condition. So if I take my initial condition and I add the number of people that have called in and I subtract the number of calls they've handled, I'll get the number of people on hold. Okay? So then when they're asking me, is the number of people on hold increasing, decreasing, or staying the same? If I want to know whether this function is increasing or decreasing, I need to take the derivative of this. What's the derivative of this? Well, the derivative and the integral cancel each other out. So I'm left with c of t. What's the derivative of 400t? 400. Okay? So they're asking me whether this is positive or negative between hour 1 and 2. Well, let's see. Between hour 1 and 2, c of t, which is this function, is 700. 700 minus 400 is 300. My derivative of my number of people on hold is positive. I'm not going to write this out, but you can listen. So my number of people on hold is increasing because the derivative is positive. Okay. C here says, at what time is the number of people on hold the greatest? How many people are on hold at that time? Okay. So I have my number of people on hold function here. I'll call it n of t. And I'm trying to find out when this is greatest, when it's maximized. So I'm going to take the derivative of it. That's what I did above. Equal to 0. There's my derivative. Set it equal to 0. Well, it's going to equal 0 when c of t equals 400, which is going to happen at time, let's look back at my graph. Happens at time 3. So time 3 hours in, is the only critical point. But they're asking me at what time is the number of people on hold the greatest. This function is defined for t between 0 and 6 hours. So I'm finding an absolute max, so I need to do a candidates test. Okay, again, this is the critical point. It might be a relative min or a relative max, but if I want to find an absolute max, I also need to consider the endpoints. So what I need to consider here is at time 0, time 3, and time 6. Which of these has the greatest number of people on hold? Go ahead and look at this function, look up at the stuff we have above, and evaluate this. Pause and evaluate that, please. Okay, so for t equals 0, no more people have called in, no calls have been processed, it's just our initial 300 people on hold. For t equals 3, 1,850 additional people have called in. I figured out that by looking at the area under the curve from 0 to 3. Okay. But they've processed 1,200 people, so that leaves 950 total people on hold. At time 6, we had our 300 initial, 2,200 people called in, but they processed 2,400, which leaves us only with 100 people on hold. At what time is the number of people on hold greatest? That's at time 3. How many people are on hold? 950. Okay. This is a classic flow in, flow out problem. Please make sure you have something like this down. This is a A-B type question that shows up on the BC exam, oftentimes on the shared questions between AB and BC. Moving forward, a couple more questions here. This is another thing that definitely is a good thing to just have down, okay? F is differentiable function. They give us a point. They give us another point. They give us the derivative at a point. They give us the derivative at another point. They tell us that we have a function g that is the inverse of f. And they're asking us to find g prime of -4. I hope when you think about finding the derivative at a point of the inverse of a function, you think about buddy points. What do you do with buddy points? I'll give you a reminder about buddy points. The first thing you do is you draw a buddy burrito. Please remember to draw a buddy burrito. They're asking us to find g prime of -4. So the x value for g is -4, which means that's the y value for the inverse. Okay? So if we're talking about a y value of -4 for f, then we're talking about an x value of 9 for f, which means a y value of 9 for g. How do you find g prime of -4? Well, you look at the derivative of f at the buddy point. So you look at f prime of 9, not f prime of -4. You look at f prime of 9, and you do the reciprocal of it. Cool. Buddy points. Check, check, check. Cool. F is this function. It's asking us on this, or sorry, it's defined in this interval. It's asking us on what intervals is f of x decreasing. Seems easy. How do you figure out where a function is decreasing? You figure out where the first derivative is negative. The thing that's a little tricky with this is you got to be able to take the first derivative of this. Okay? This is the accumulator. The accumulator function. When you take the derivative of the accumulator function, the derivative and the integral cancel each other out. But there's an asterisk there because there's some nuance to that. So I hope we can remember this. First, when I look at this accumulator, I go, wait, the constant's supposed to be on the bottom and the x is supposed to be on top. That's cool. I can flip this. But when you flip the bounds, you got to add a negative. Okay? So I'm going to rewrite f like this. How do I do the derivative? Well, now that it looks like this, the derivative and the integral cancel each other out. That's fundamental theorem of calculus, and I'm just left with this. So f prime is just -x sine of 2x. In order to figure out where the function is decreasing, I need to figure out the critical points. Well, I'm going to take the first derivative and set it equal to 0. Okay? When does this equal 0? That is something you should be able to solve algebraically. It equals 0 at 0. Negative pi halves and pi halves, negative pi halves and pi halves, because they make sine of negative pi and sine of negative pi and pi are both 0. Once you have these critical points, you're going to throw them on a sign chart. You're going to plug in x values here, 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 here. You're going to plug them into the derivative. You're going to figure out that it's increasing, decreasing, decreasing, increasing. And so where is it decreasing? From negative pi halves to pi halves. In order to be able to do this, you need to be able to evaluate trig functions. You better be able to plug in pi fourths and say negative pi fourths times the sine of 2 times pi fourths. Well, 2 times pi fourths is pi halves. Sine of pi halves is 1. Negative pi fourths times 1 is negative. Okay, so you better be able to do that. This is a good check for you that you remember that stuff. Okay. Okay, last question here. Okay, they give us a graph of f of x. It's a geometry graph. Okay, it's got lines, semicircles. This is nice. They're talking about some other function, big f of x, which is the accumulator of little f of x, from 1 to x. They're asking us to arrange these f of 0, f of -2, f of 3, and f of 5 from largest to smallest. Well, I'm just going to evaluate each of these. Okay. If I want to evaluate f of -2, I'm going to find the area underneath little f from 1 to -2. If I want to find f of 3, I'm going to find the area under f from 1 to 3. For 5, the area under f from 1 to 5. Go ahead and pause, take a minute, see if we can figure out which of these is biggest and smallest. Okay, so just to run through these real quick, I'll start with this one, f of 3. Area underneath the curve from 1 to 3, it's just a semicircle, check. From 1 to 5, I have that same pi, but then I got to take away 1 because it's below the x-axis. For this last one, this first one, it's from 1 to -2. I'd flip it and say, oh, it's the area from -2 to 1, but then I got to do the opposite of that. Well, the area under the curve from -2 to 1 is, that cancels with that. It's +2, but I have to do the opposite of that because I had to flip the bounds, and so it's -2. So from largest to smallest, it'd be 2, 3, 1. Boom, boom, boom. That concludes this video. Thanks for watching, guys.